Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our second video on the use of the nth term of a quadratic sequence. Let me start with a skill I expect you to know and need you to know for this particular video. I'd like you to pause the video and for each of these two questions, solve for x. Okay, I would have liked you to realise they are both quadratic. In order to solve a quadratic, you need to make one side equal 0, so you would subtract 42 off both sides of the equation. On this side here, you would have x squared, add x, subtract 42 is equal to 0. You'd try then to factorise before you tried completing the square or using the formula. That does factorise to x add 7, x subtract 6 is equal to 0. And then you could solve. That gives you one answer when x add 7 is 0, or another answer when x subtract 6 is 0, and on this side you would get x therefore is negative 7, and over here you would get x is therefore positive 6, and there are your two answers. In this case, you'd first expand your brackets, it's your only real option. You'd get x squared subtract 3x is equal to 130. You'd subtract the 130 off both sides. To get x squared subtract 3x subtract 130 is 0. You can only solve a quadratic when one side is equal to 0. Try and factorise that. It does factorise. It factorises as x subtract 13, x add 10 is equal to 0. Therefore, one set of solutions comes from x subtract 13 is 0, or you get the other one from x add 10 is 0. Adding 13 to both sides, x is 13. Subtracting 10 from both sides, x is negative 10. So I need you super good at being able to find the solutions to quadratic equations like that. I also need you familiar with one other skill we did with linear sequences, and it goes like questions like as follows. We're told the nth term of this sequence 3, 7, 11, 15, 19 is given by the formula Tn is 4n subtract 1. I'd like to ask you, is 405 a term in this sequence? Pause the video and see if you can remember how to do that. Well, we are given the nth term, a formula for the nth term. So if 405 was a term in the sequence, the expression for the nth term, 4n subtract 1, must equal 405 for some whole number n. Remember, n stood for the position of a term. So if we can find a whole number n that solves this equation, then 405 is in the sequence. If we get n being a decimal or a fraction, not a whole number, then n is not in the sequence. So we'd add 1 to both sides and get that 4n is therefore 406, and we divide both sides by 4. Now it turns out when you divide both sides by 4, let's do the division over here. 406 divided by 4. Does 4 go into 4? Yeah, one time. Does 4 go into 0? No times. Does 4 go into 6? It goes in one time, but remainder 2. So you put a decimal there, put 2 there, and then does 4 go into 25 times? So because we get the answer 101.5, n is a decimal, so therefore n is could not represent a position in the sequence, so 405 cannot be a term of the sequence. The other way around, if we had got n being something like, let's say 102, a perfect whole number, then that term would have been in the sequence. Okay, let's try and apply the same logic to quadratic sequences. If you feel like you can, pause the video and have a go at this. Well, this time we're given the nth term of a quadratic sequence is 5n squared subtract 2. We're asked, is 123 a term in the sequence? If it was, then 5n squared subtract 2, the nth term, must equal 123 for some whole number n. Let's add 2 to both sides. 5n squared would therefore be equal to 125. Let's divide both sides by 5. I would get therefore that n squared would be equal to 25. And I take square roots of both sides. N is therefore positive or negative the square root of 25. Now, I'm going to ignore n being negative root 5. There is a solution n being negative root 5, but that is irrelevant to me. N in the case of sequences always must be positive integers, whereas the other answer is n is 5. Now, because I have found a whole number answer for n, then I know that 125 is a term. It is the fifth term of that sequence. Okay? What about the same for 998? The same logic would apply. We do 5n squared subtract 2 is equal to 998. We'd add 2 to both sides. 5n squared is therefore equal to 1000. We divide both sides by 5, n squared is therefore equal to 200. And if I try to take the square root of 200, positive or negative, if you type in the square root of 200 on your calculator, 200 is not a perfect square and you get a surd. So therefore the answer is no, n is a decimal, so 998 not in the sequence. And we're done. Let's have a go at another one. Pause the video and have a go at these two. Same old stuff here. If 49 was a term in the sequence, then our nth term, n squared, add 3n, subtract 5 is equal to 49, would be able to be solved where n was a whole number. Let's subtract 49 off both sides to make the quadratic equal 0. N squared, therefore, add 3n, take away 54 would equal 0. Can we try and factorize this? Well, it looks potentially hopeful. Let's have a go. That goes n add 9, n subtract 6. That factorizes 2. And therefore, on the one hand, n is negative 9. And on the other hand, from this side, n would therefore be positive 6. Clearly, you ignore the negative n. N always has to be a positive whole number. But here, that gives us the answer we're looking for. So, is 49 a term in the sequence? Yes, it is. It is the 6th term, i.e. when n is equal to 6. And if we had a go at this one, is 20 a term in the sequence? Well, I'd solve n squared, add 3n, take away 5 equals 20. I'd take away 20 from both sides. N squared, add 3n, take away 25 is equal to 0. Now I try as hard as I can to think of two numbers that multiply to negative 25 and add to positive 3. Just think of the factors of 25. There are only 1 multiplied by 25 and 5 multiplied by 5. And neither combination of those can add up to anything like positive 3. This doesn't factorize. You can't get a whole number solution for this. And in fact, the answer is definitely going to be a decimal. So therefore, you could say n is a decimal answer, and you could say therefore no, 20 is not in the sequence. Okay, and just to point out here, when you factorize, that's when you get whole number solutions here. If I did use the quadratic formula, I could go ahead and use the quadratic formula where a is 1, b is 3 and c is negative 25, but trust me, I would definitely get a decimal answer there, and it wouldn't be worth the effort to work out. I can just tell that because I can't factorize that I'm not going to get whole numbers. Right, let's try another one. Pause the video and have a go. Okay, in this one, we've got the nth term here given by this complicated expression. We're asked, is 99 a term in the sequence? If it was, then this expression n subtract 4, add 3 would equal to 99 for some whole number, positive whole number n. Let's see if we can solve this. This would be n squared subtract 4n, add 3 is equal to 99. Let's subtract 99 off both sides. That would be n squared subtract 4n. 3 subtract 99 is negative 96 equals 0. Can we factorize this? Well, we can. That factorizes as n subtract 12, n add 8, because negative 12 multiplied by 8 is equal to 96, and negative 12 add 8 is equal to negative 4. So that does factorize. This gives us n subtract 12 is equal to 0, in which case n is 12, and it gives us n add 8 is 0, in which case n is equal to negative 8, and we clearly ignore that solution because we don't care about negative n. So the question was, is 99 a term in the sequence? Therefore the answer is yes, 99 is a term. It is the 12th term of the sequence. And that's it, we're done. And that's it for this particular video. Thanks loads for watching.